Hello everyone. Welcome to watch this micro class. This class we are talking about building lightning protection grounding system. There are the following 5 aspects. Lightning is a common natural phenomenon in our life. There are lightning activities in all corners of the world, from ancient times to the present. Do you know how lightning is formed? We know that clouds are composed of many small water droplets. The droplets and airflow in the cloud cluster will generate electric charges during the friction impact process. Generally, the upper part of the cloud is negatively charged, while the lower part of the cloud and even the ground are positively charged. When the electric charge accumulates to a certain extent, the electric field strength between the clouds, or between the clouds and the ground, exceeds the breakdown strength of the air, the discharge is formed, which is accompanied by the process of luminescence and heating. The light produced by the discharge is what we see as lightning. The heat release causes the surrounding air to expand violently and make a strong vibration, which is what we hear as thunder. We all know that lightning is very dangerous, and the harm caused by lightning is also shocking. Lightning disaster is one of the 10 most serious natural disasters announced by the United Nations International Decade for Disaster Reduction. We can see the seriousness of the harm it brings. Its common damage mainly includes thermal damage, mechanical damage, breakdown damage. Thermal destruction is a phenomenon that generation of enormous heat to cause objects to burn and melt metals. Mechanical damage refers to the huge electric force and heat generated by the strong current passing through the object, which causes the internal pressure generated by the rapid evaporation of water in the object to cause the object to split. Breakdown damage means that insulation material in electrical system is broken down by extremely high voltage, resulting in short circuit between phases, and the damage scope and degree is rapidly expanded and increased. For buildings, the common types of lightning are direct lightning, lightning induction and lightning wave intrusion. The main damage of direct lightning is the direct discharge of lightning to electrical equipment or buildings, and the lightning current can reach tens of thousands, or even hundreds of thousands of amperes. The damage to the building is very big. Even serious explosion and fire. Lightning induction occurs because the gradient of lightning current variation is large during direct lightning discharge, so that the alternating magnetic field is generated, which makes the metal components generate large induced electromotive force, which makes the metal components live and damages the electrical equipment. Lightning wave invasion is a kind of lightning current along the overhead or buried shallow metal pipeline into the indoor site, which often leads to electrical equipment damage. Human body electric shock accidents. Lightning hazards have certain rules. According to statistics, the parts that are easy to be struck by lightning are high and protruding parts, such as water tower, chimney, roof corner, gable, parapet, etc. Buildings with different roof slopes have different lightning strikes. The lightning strike rate of roof corner and eaves corner is the highest, and the greater the slope of roof, the greater the lightning strike rate of roof ridge. When the slope is greater than 40 degrees, the eaves will not be struck by lightning. When the roof is less than 27 degrees, and the length is less than 30 meters, the lightning strike point will mostly occur in the gable, and the eaves will not be struck by lightning. Buildings are divided into 3 categories according to their importance. Use nature, possibility and consequences of lightning accidents. The first category is mainly inflammable and explosive dangerous environment. The second category is mainly National Key Cultural Relics Protection Buildings, National Hall Exhibition Center, office buildings and other buildings or structures, and provincial and ministerial buildings, with a high number of expected lightning strikes. The third category is the provincial key cultural relics protection buildings. According to the annual calculation of the number of lightning strikes reaches a certain value for the provincial and ministerial buildings, and the general civil and industrial buildings with high lightning strikes, because the lightning phenomenon will bring harm to our personal safety and electrical equipment. So we must take effective measures to prevent accidents. The following lightning protection device can effectively prevent direct lightning damage to us, and it is also our most common external lightning protection. Lightning protection device consists of 3 parts. The first part is lightning arrestor. The second part down lead. The third part grounding device. How does it prevent direct lightning damage to buildings? We know that when a lightning strikes a building, it creates a powerful lightning current, which can cause damage to our buildings. We know that the earth is a huge capacitor. No matter how much current is input, the electromotive force tends to zero. If these lightning currents can be scattered to the earth, then our buildings will be safe. The lightning protection device is based on this principle. The research shows that the parts of buildings that are easy to be struck by lightning are the protruding parts and edges on the roof. Therefore, the lightning arrestor of the lightning protection device is installed at these parts of the roof to guide the lightning cloud to discharge to the lightning arrestor, and the lightning arrestor transmits the received lightning to the down lead connected with the lightning arrestor. The down lead then transmits the lightning to a grounding device buried at a certain depth in the soil, which rapidly disperses the lightning to the soil, thus preventing buildings from being struck by lightning. Next, we will learn the specific construction process of each component of lightning protection device in detail. The first part is lightning arrestor, which is located on the roof of the building and leads the lightning to itself by virtue of its prominent position higher than the protected object. There are 3 common forms of lightning rod, lightning belt, and lightning network. Generally, the lightning rod is galvanized round steel or galvanized steel pipe, and the upper part is made into the shape of needle tip. The length of lightning rod is generally 1 to 2 meters. The diameter of round steel shall not be less than 16 millimeters, and the thickness of steel pipe shall not be less than 3 millimeters. The lower end of the needle body is connected with the down lead. Lightning rods are generally used to protect tall and narrow buildings, such as St. Basil's Church in Russia, the Eiffel Tower in France, the Wooden Tower in Yingxian. For buildings with low height and large roof area, it is not suitable to use lightning rod as lightning protection. As we said earlier, buildings are subject to a certain regularity when struck by lightning. The most likely places to be struck by lightning are the ridge, eaves, parapet, and the edge of the flat roof. Then we can install lightning strips in these places. Generally, the lightning strip shall be galvanized round steel, with a diameter of not less than 8 millimeters, or flat steel with a sectional area of not less than 48 square millimeters. Every 1 meter, 0.5 meters at bends, fixed to parapet wall etc., with brackets. In order to ensure the continuity of lightning current conduction, the connection between lightning strips shall be reliable. Generally, lap welding is adopted. Take galvanized round steel as an example. The lap length shall not be less than 6 times of the diameter of round steel, and it shall be welded on both sides. At the same time, if the lightning strip needs to pass through settlement joint, expansion joint, etc., it shall be made into semicircle pattern in the drawing, to avoid breaking the lightning strip when it is deformed. The down lead leads the lightning current from the lightning arrestor to the grounding device and discharges to the earth. At least 2 down leads shall be provided on the building. Down lead has 2 forms. One is manual down lead. That is, made of galvanized round steel or flat steel alone. The second is the natural down lead, using the reinforcement and escalator in the building body structure. For example, the main reinforcement in the structural column is used as the down lead. The manual down lead is generally made of galvanized round steel, with a diameter of not less than 8 mm, or flat steel with a section of not less than 48 square millimeters, and a thickness of not less than 4 mm. And in order to measure the grounding resistance and check the connection between the down lead and the grounding device at 1.8 to 0.3 meter from the ground, disconnect clip shall be provided. When the main reinforcement of building structure column is used as down lead, when the diameter is generally 16 mm and above, 2 diagonal main reinforcements are used as a group of down leads. 4 bars shall be used as a set of down conductors when the bar diameter is 10 to 16 mm. At the same time, in order to ensure reliable connection, lap welding is generally adopted, with lap length not less than 6D, reinforcement welded on both sides, and marked with paint as down lead. To avoid confusion, the upper part of down lead must be lap welded with lightning strip. In order to ensure the continuity of lightning current conduction, it is not allowed to be welded with supporting clip. At the same time, the connection plate can be set at the outer wall 0.3 meter away from the ground to measure the resistance without disconnecting clamp. The grounding device is buried underground to receive the lightning current from the down lead and discharge it into the earth at the fastest speed. Grounding device includes grounding wire and grounding body. Grounding wire is a metal wire used to connect down lead and grounding body, and flat steel with section no less than 25 square millimeters and thickness no less than 4 millimeters is commonly used. Grounding body is divided into artificial grounding body and natural grounding body. Artificial grounding body refers to the metal conductor buried in the ground artificially. Artificial grounding body can be divided into horizontal grounding body and vertical grounding body, also called grounding electrode. Vertical grounding body buried in soil usually adopts galvanized angle steel, round steel and steel pipe, and its length is generally 2.5 meters. The spacing between vertical terrains is generally 5 meters. Natural grounding body, pole, refers to all kinds of metal components directly contacting with the earth, such as reinforced concrete pile foundation of buildings, buried metal pipes, etc., which are also used as grounding. As shown in the left figure, the ground ring beam is used as the grounding body, and the main reinforcement in the pile is used as the grounding body in the right figure. At the same time, we have to set up equipotential bonding for the safety of buildings and people. Let's find out what an equipotential is through a short article.
Equipotential connection. It is to remove all metal objects near the building, like steel bars inside concrete supply line, gas pipe, and other metal pipelines. Machine metal object and other large buried metal objects. Cable metal shielding layer. Zero line of power system. Grounding wire for buildings. Unified method of electrical connection. Connect it together. Make the entire building, becoming a good equipotential body.
Equipotential bonding can effectively reduce the potential difference generated by lightning current among the above components and equipment. Equalizing the potential and reducing the contact voltage are measures to eliminate the electric shock risk caused by the potential difference. Equipotential bonding is generally divided into general equipotential bonding and local equipotential bonding. The general equipotential bonding is the connection of the general protective conductor the general grounding conductor, or the general grounding terminal, the metal pipes in the building, and the conductive parts, such as the available metal structure of the building. Local equipotential bonding is to connect the PE line, or Peruvian Soles line, to all nearby exposed conductive parts and external conductive parts within a local range. Make them at the same potential in the local range as a supplement to the total equipotential connection. The main purpose of local equipotential bonding is to reduce the contact voltage below the safety voltage. As shown in the figure, local equipotential bonding in the bathroom is a common local equipotential bonding. It is mainly used to connect protective wires, metal water supply and drainage pipes, metal bathtub, metal heating pipes, and ground reinforcing mesh of various sockets in the toilet. Through equipotential connecting wires, the local equipotential connection terminal plate shall be connected by bolts, generally connected with the reinforcement mesh, through galvanized flat steel, and the others are connected by concealed laying, through plastic pipes through conductors. Students, although the equipotential connection is small, but it is very important for our construction equipment safety and personal safety, whether it is the decoration of their own homes or the construction industry in the future. We should pay high attention to it. Only by not relaxing the control of every detail can we make a fine building. Welcome to continue to watch other videos of the construction equipment installation project course.